Alright, hello everyone, this is Mr. Crozier. I wanted to give you a video help here for what we're going to do when we have problems that look like this. Sine of 3x is equal to a half. Well, we don't have a formula for sine of 3x. We have a double angle formula, but not a triple angle formula. There is a triple angle formula out there. It's pretty complicated, so it's going to be easier to do it to work manually. Now the plan we're going to use here will also work for any time you have a trig function of a multiple angle problem here. 7, 4, 5, 4, doesn't matter. As long as you have one trig function equaling one number, this plan will work. And our plan is simply find and use the general solution. Alright, I'm going to show you what this means. And you can use this plan on any type. When you get any problem like this, use this plan. So here we go. Alright, what we do is we simply pretend, and I'm going to do the work over here, we just pretend it is a sine x 1/2 problem. We just ignore this for the time being, and we'll let that go. And then we solve this. And when does x equal 1/2? Well, x is equal to 1/2. X is equal to 1/2. Let's see here. Where is that? That's pi over 6. And x is equal to 5 pi over 6. So those are our two solutions. Fairly obvious. And right here is a graph of a sine of x function. And the function goes from 0 to 2 pi. And where is it 1/2? Well, right here is the half line. And this point right here would be pi over 6. And this point right here would be 5 pi over 6 because it doesn't go there. And that solves the problem for us. Alright, well, how does that apply to here? Well, we do the same thing, but we just bring down the 3x, and we have pi over 6, and we have x is equal to 5 pi over 6, and we just make that 3x. So we make it exactly the same. And then what we do is we go ahead and we multiply. We just multiply both sides by a third or divide by 3, however you want to think about it. And these are our solutions. That's pi over 18, and this would be 5 pi over 18. And that is all well and good except for one thing. There's more solutions than just this, and I'll show you why in a second, but these are the first two solutions, but we are not done. Watch what happens down here. If this is a graph of y of sine x, watch what happens when I make it 3x. Do you remember what that does down here? The period of this one is 2 pi. The period of this one would be 2 pi divided by 3, meaning the period got smaller. And I made these marks here. Here's 2 pi over 3, and here's the next one, and there's the next one. So I took my period of 2 pi and I divided it by 3. 1, 2, 3. That means this sine function goes up and down right there. Then it also goes up and down right there. Then it also goes up and down right there. The period got divided by 3, so there's really 1, 2, 3 waves. So now there are 1, 2, 3, 4, 5, 6 answers. And we have to find them all. What we found up here, this one is right here, pi over 18. This one is right there, 5 pi over 18. However, there's 1, 2, 3, 4 more solutions we have to find. And that's going to be done by going back to the general solution. So here we go. Alright, what did we need to do up here? This was not just pi over 6, but it's pi over 6 plus the number of loops going around. However many loops we want to go around, and plus 2 pi n, the number of loops. Because the solutions are here, and every time you go around the circle, it's another solution. So when I divided this by 3, this is the true solution here. This is the true solution of the equation. Alright, so let's use these to generate all the solutions in this interval. And it's going to be done by counting n. We're going to start with n is equal to 0. Let's start here. If I have pi over 18, and I add on a 0 here, that would be none of these, so this would just be pi over 18. Now what I'm going to do is I'm going to pretend n is 1. Well, if n is 1, I have the problem pi over 18 plus 2 pi 3. Because if I put a 1 there, that's just 2 pi over 3. Let's just make this common fractions. Whoops, don't need a comma there. And common denominator, sorry, times this by 6, that's 12 pi times that by 6 is 18. Alright, so you see what's going to happen. I'm going to add on 12 pi. So I'm at, my first solution is pi over 18 plus 12 would be at 13 pi over 18. And then if I plugged in a 2, where should I write this? N is equal to 2. Well, now I'd have 2 of these. So this would be a 4 here. And this would be a 24 here. And I'm just adding on that, and I'm up to 25. Can I erase this here? So I'm at 25 pi over 18. And do you see what's happening here? What I'm really doing each time is I'm counting by 12 here, and I'm adding on 12. And the way you can see that is if you have 2 pi over 3 times 6 is 12 pi over 18. So you're adding on every n, every loop, you're adding on 12 pi over 18. So I'm at 1 plus 12 plus 12. And what is the next one? 12 more would put me up to 37 pi over 18. But 18 goes in there more than twice, so that's not a solution. So these are 3 of my solutions. And if you want to see them on the graph, ready? They're right here, they're right here, they're right there. And we go 12, 12, and we keep counting. Alright, let's see if we can't do the second one a little bit quicker. Well, where am I starting at? I'm starting at 5 pi over 18. And I'm going to count by 12s over and over and over again. If I add on 12, I'm at 17 pi over 18. If I add on 12, I'm at 29 pi over 18. If I add on 12, I'm at 41 pi over 18. 18 goes in there more than 2. It's outside of our interval. So those are my last 3 solutions. And where are they on the graph? I always think it's kind of neat to see them on the graph. Here's the first one. Go over 12. There's the second one. Over 12. There's the third one. So these are our 6 solutions. Pi 18, 13 pi 18, 25 pi 18, 5 pi 18, 17, 29. Alright, again, just to kind of summarize, this plan works and it's what you need to do. This is probably the longest problems we have in these equations, but it works for anything like this. You have to find the general solution. You have to find it written out like these boxes here. Sometimes you can combine the boxes to just give yourself one. Sometimes you'll have both. And you just start at the beginning and count by what it says. Make sure you have common denominators, though. You can't add 18s and thirds. Have to get common denominators. And just keep counting up until you get outside your interval. Alright, it will work on all of them, and this is a plan we have to use. Otherwise, we're only going to find some of the solutions. Like at the beginning, if you don't add on this general solution, I know it's a lot, but if you don't add on this general solution here, you're only ever going to get the first 2 solutions. And by the look of this graph, there's a lot more solutions to find. Alright, I hope this helps.